I think the first time for you guys to join, Sean and Venkatesh.
Hey, yeah, it is. Good morning.
Good morning.
Yes.
If you want, you can do a brief introduction, maybe about your company or where you're working at or what topics you're working on, so everyone knows.
Yeah, absolutely. So I'm a machine learning engineer at a company called NICE, where the team I work on it's essentially an applied AI research team. We're working on basically applications of language processing for call center agents. So NICE produces call center software as a service. And then what we're working on is augmenting call center agent capabilities just using AI techniques.
Nice. And then doing some entity extraction, text classification, or also some more specific tasks.
Yeah, so right now it's focused on, we have other teams there that do similar stuff like that for reporting and analytics on the call centers. Our team is more focused on how can we make agents more productive, and then eventually can we actually replace call center agents with automated agents.
Yeah. And then the LLMs come in handy, I would say.
Yeah, helping people navigate a little bit of the hype there for sure. But...
And how about you, Venkatesh?
Yes, I'm working in a startup in India. So we are building a platform. So where companies can integrate their databases and then play with question answering, interacting with the documents kind of thing. For example, if you assume that there is a HR policy documents are there, so instead of sharing, you can check it out. You can ask simple question. Okay, how many leaves are you can avail? Or you can interact with real databases. Okay, my account is already plugged in, so I can ask simply how many leaves are there, what is my favorite, who are my team members. So this is one kind of thing we can simple increase the productivity of the employees. So we are creating multiple projects. So you can create one project for HR policies, one project for teams, and project for any document, any code base or PDF or Markdown. It can be anything. I think you're on mute.
Yeah, the audio it doesn't always filter out properly, so I muted myself. But as I said, then also working on RAG and these kind of things too, Venkatesh? Or
sorry,
I said you're working with RAG as well.
Yeah, RAG as well. We are also getting summaries. Right now, we are focusing, of course, RAG is almost we implemented. We are testing about the performance like parent retrieval and multi-document self question answering kind of thing. We are about to switch to we are seeing the benefits of creating agents. People can create custom agents. That's we are focusing mostly on the agents because RAG, we already become standard RAG. Everybody we know basic thing, but advanced we are not sure. But we are focusing on if you're having large databases kind of thing. That's we are focusing mostly on the unstructured data. Of course, structured data we have. So we are focusing on the unstructured data completely.
Yeah, too.
RAG plus agents. And yes, we are also focusing not only RAG, this part we can do, but with security, privacy, that's also matters.
Yeah, the actual difficult part.
Yes, exactly.
Maybe normally wait a couple minutes to get started, but I guess I can already start presenting. Yeah, nice to have all of you here to the meetup again. So this Christmas edition apparently, and I updated my background just to make it a bit more fun. In the bottom right corner, you can actually see a Q&A thingy where you can ask questions throughout the presentation if you have any. And the session is being recorded. So if any one of you has difficulties with that, you can either disable the microphone or your camera or these kind of things. And yeah, just listen in and type. So briefly, I will first start with an introduction about what Argilla is and how we see Argilla, distilabel, and the new package that we intend to introduce, TypeScript, Argilla TypeScript, to be able to log data from Argilla, from third-party applications running LLMs to Argilla. And then after that, I will briefly showcase a notebook about synthetic data generation and walk you through there. And feel free to ask and talk about these kind of things and ask questions also about the implementation. Let's see. Perfect. I think all of you can see my screen, correct? Yeah.
Yes.
Okay, so yeah, Argilla is a data annotation platform, and what we see is in order for models to be secure and safe, and to understand your business. So we want to be very powerful tools in order to do these kind of things. But in order to completely do that properly, and to ensure that they fully match everything within your company and your ecosystem and the way that you think and what the culture is, you actually need to teach them. And the most effective way to do that is actually through the gathering feedback, and that's what it's all about. And that's also what the main ingredient is for all of these powerful LLMs hosted by OpenAI, Cloud, Bard, Llama 2, but also the new phase of LLMs with all of these open source alternatives that are out there, like Phi and Nodus that we recently released. And this is also, I think that we've seen come back a lot. So Argilla is an open source platform to improve enterprise LLMs with human and AI feedback. And we actually do that through two ways. So on the left-hand side, you can actually see this more user-oriented UI that's very focused towards more domain experts and business stakeholders. And on the other side, you can actually see the Python SDK that's really focused on setting up databases, configuring everything, and also evaluating the responses through metrics and these kind of things. And that's also a thing that we recently released in the release that we published today, 1.21, and that Agustin has been working on a lot. So thanks for that. Yeah, maybe you've seen recently the case study or the blog that we shared about the Notice model that we've released, which also really highlighted that high quality data and actually knowing and understanding what's within your data actually helps in terms of improving model performance. Because we actually found some flaws in that data set, which was also used for training Zephyr, a model from the Hugging Face H4 research team. And by just reevaluating the data and reevaluating the quality of the data and kind of adapting it to that specific to our specific use case and to our quality standards, we actually managed to reuse everything from their training and actually get a way better model out of that according to the benchmarks, but also according to human evaluation. So what Argilla is basically this ecosystem where Argilla Cloud hangs a bit above the rest and is also not open source. And then we have distilabel, Argilla Core, and Argilla TypeScript, where distilabel and Argilla Core have already been developed and are actively being pushed, and TypeScript is soon to be released. I will go over each one of them one by one. So Argilla Cloud is really the enterprise version of Argilla for larger teams, so with more complex and distributed workflows and annotation schedules and these kind of things. Then there's Argilla Core, which is fully open source, the platform for orchestrating human and AI feedback for small and large language models. So this will also means that we really want to include human and AI and smaller and large language models, because eventually you want everything to be as efficient as possible, as cost efficient as possible, and also be able to actually evaluate things instead of just using GPT-4 to evaluate ChatGPT, for example. So eventually we do believe that there's going to be a loop. This is what that would look like in the UI, where it's fully configurable. For example, for RAG pipelines, you can store the documentation that you might have for like conversational flows. You might have a prompt and response, as you can see on the left-hand side. And on the right-hand side is the focus on what your annotator team is going to collect in terms of feedback. And this can also be enhanced with like suggestions and these kind of things. But to get started, you really need to always think about the workflow and the problem that you have in order that your data that you're collecting is actually high quality. And that's a thing that you need to keep in mind. And that's also a thing that we provide full support for, and complete configuration options and these kind of things to fully tailor to your needs, so to say. Then within Argilla Core, what you can do is actually configure workspaces, datasets, and users. Then when you have some data coming in, you actually start creating records or data entries within your dataset, which can be assigned to users. And then along with that, what you do is combine the human feedback also with AI feedback. And we actually do that in the forms of vectors, metadata, and suggestions. And these things allow for your users to actually filter and query and annotate the data way more efficiently. When you're, for example, doing vector search, you can do finding most similar records. When you have some pre-configured, configured metadata elements. You can actually filter and sort based on these kind of things. And that actually is the way that we see silver data being enhanced by AI feedback. Then that silver data together with human feedback will actually return responses and eventually turn into golden data, which it then can use to do training and to do evaluating of the initial suggestions compared to the responses. And this will actually return some metrics. And this is also where you can see the kind of loop coming in for where you have a trained model, you get some feedback, you give some feedback to the initial records that you have coming in during inference. Then human feedback will ensure that's golden data, and that's the MLOps loop or the human feedback loop that we have in there as well. And then your model will improve over time. Then there's also a distilabel, and this is also what the tutorial after this is going to be about. So synthetic data generation, getting knowledge from LLMs in order to actually skip some of the predefined steps that you need for testing things in the real world, so that you can bootstrap or kickstart any NLP project, then do the curation also within Argilla, and then eventually end up with high quality data set or high quality model even that you can then already deploy. And of course, these things play nicely together. And that's what you see here, where you use the distilabel package as a generator and as a labeler for actually generating this synthetic data set that you might need for preference tuning, that you might need for all of these more tailored scenarios. And this data set is once again considered as silver data initially. And together with Argilla, together with your annotation team that you've actually guided and educated about the task, you will actually get this golden data. And this golden data can then be used within the Argilla trainer and eventually will return fine-tuned LLM, really specifically tailored to your domain, and preferably also being a bit smaller than the LLM that you originally had. Then finally, there's Argilla TypeScript, which you can use for logging data back into Argilla core. And this is how these things play together. So you've got distilabel with a general model that continuously synthesizes data and labels data through AI feedback, resulting in some silver data. Then after that, the silver data with some human feedback will turn into golden data. Eventually, you'll get some metrics and a trained model, once again, resulting in this feedback loop. So that's the brief introduction about Argilla, about distilabel, and about Argilla TypeScript. And then next I will go to the notebook that I've prepared about synthetic data generation. So for this notebook, what I've done is actually outlined how you might use LLMs to kickstart NLP projects with synthetic data generation and labeling. And this notebook is really focused on having everything available within a Google Colab, with a free Google Colab GPU. And this should be completely reproducible using open source models and using publicly available data, compute, and everything. So it can be used by anyone everywhere. LLMs are quite diverse, what we've seen, and they can actually be used for synthetic data generation. And that's also what the distilabel package is about. And in this example, we'll actually combine the distilabel package together with vLLM and setfit. And setfit will be used as a basic classifier to get some initial knowledge from that. And vLLM is actually an LLM serving engine or inference engine. And that's actually the way that we are going to extract and distill knowledge from the LLM. So first, let's install all of these packages. Then we can handle some of the imports. For Google Colab, I'm also importing user data, which is basically the equivalent of environment variables. What I've already done in the background is also set up Argilla, and that can actually be done for free as well on Hugging Face Spaces. And this Hugging Face Spaces deployment or quick start can be as easy as a click of a button, where we might quite easily go here and then press deploy on Hugging Face Spaces, and you'll actually end up with a very easy way to deploy Argilla. In this case, just giving it a name, like data science, for example. Then opening the Docker templates and these kind of things, setting up secrets maybe for authentication, for some team differentiation, for role-based access control and these kind of things. And then deploying the space. And what this will do is actually host a Docker container for Argilla, and within the Docker container, we actually have Elasticsearch, we have PostgreSQL, a Vue, UI, and some other things. For now, actually already created this container, so I will be connecting to one of the existing containers that I have up and running. Besides that, what I will do is actually load Llama 2 as one of the established older LLMs, but it's the one that was easily available by the bloke on Hugging Face. And this guy actually also managed to quantize the model for me. And that's also why it's able to load and run inference on a Google Colab GPU, because it will actually ensure that the model is smaller and a bit quicker than originally with the original weights. I actually already initialized the LLM. Next, what we will do for using this distilabel is we will actually use it for synthetic data generation. And that can be done through this package, which is publicly available, where we have some predefined tasks in order to bootstrap projects for either preference data collection. But I will now actually showcase how you can use it for initially for predictive tasks, and then later on we'll use it for more generative LLM-oriented tasks, so to say. So what we will do here is actually initialize the model, where we'll initialize a data set where, as mentioned, it's always really important to think about what you want to do and achieve with your data set. In this case, the data set name is going to be synthetic customer data for a bank, for a customer service bank. And what we'll focus on is trying to generate customer service requests for that bank for a certain set of topics. In this case, it would be account balance inquiries, credit card applications, and some other things. And that's the synthetic topics that will forward to the LLM to actually start generating this synthetic data. On top of that, we also want to assess and address the severity of these requests to see how important they are to be handled by the customer service account. And later on, we will actually make some suggestions, make some initial model predictions through the AI feedback that I mentioned in order to actually easily and conveniently label this. So what we can do now is actually initialize. We can actually initialize this data set. And what will happen is that the dataset is going to be created in Argilla, and we can actually go into the Argilla UI and see that the dataset is here, but there's no data present, but that we have some fields that we can also update to, for example, use Markdown, and some questions with the bank topic, the severity, and the labels that we can see here. So next, what we'll do for the distilabel package for the synthetic data generation is provide these bank topics as inputs within a data set. And this data set is basically an initialized data set from the Hugging Face library with a list of these bank topics attached to a column called input. Next, we will actually create a prompt, and this prompt is going to capture all of the information that we have for, so to say, the use case that we sketch for this synthetic data generation. In this case, the bank is called Argilla and operates in the city of deeplearning.ai. And the reviews that can cover are complex scenarios with various human emotions like happiness, sadness, anger, to provide as much context and as much information to the LLM in order to ensure that it can actually start generating responses in a proper way. Of course, you can go quite deeply with, there was one question just joined right now, dataset for RAG, or just a dataset with question answering. This is a synthetic dataset. This dataset, or the approach that we have, can actually be used for any arbitrary dataset. So also for example, retrieval augmented generation or these kind of things. And what we will now actually do is use the initial information that we have defined as a prompt and have defined as topics for a banking scenario to actually start generating a synthetic data set that you might later on use for fine-tuning models, for evaluating with humans to ensure that the quality improves. And that's what the presentation is about today. So then next, the text task description can actually be forwarded to a text generation task, which we've imported. And this text generation task can actually be used within vLLM LLM. In this case, we'll also provide a prompt format of Llama 2, of the model that we're using, to ensure that the data is actually formatted in a correct way. I will pass some things like some parameters for the generation, like the max number of tokens and the temperature, like temperature being equivalent to roughly something that would mimic human creativity. But then, I basically boils down to more uncertain sampling from the LLM distribution. So next, what we'll do is initialize a pipeline where we forward this predictive generator, and we'll set the pipeline to generate for the dataset that we've defined, and we'll create 10 generations for each one of these topics. So from this basic setup where we describe the scenario and where we have set up these 10 topics, so to say, we'll be able to generate a whole lot more examples. And this whole lot more examples is in this case going to be 100. So for the 10 topics that we had, we're going to create 10 different annotations, 10 different scenarios that you might use for kickstarting your project. And this is actually running on a free Google Colab GPU and is directly available to use. But you can also use things like OpenAI, some other integrations that we have with Hugging Face inference endpoints. We'll plan on adding support for way more of these kind of things. Next, what we'll do is loop through all of these data entries. With regard to the question that just came in, I will come back to it later after the presentation. So next, what we will do is actually loop through all of these data entries to create a list of text and topics that we can then use to actually create a data set within Argilla. So besides the text that we've generated and the initial topics that we used, which can also be used as labels within the bank topic question that we've defined, we also use a Hugging Face sentiment pipeline out of the box to assess the severity of each one of these reviews that we found. So what we can actually see here is that here recently someone attempted to check my balance account with the Argilla app, but it was frustrating. There was this frustrating error message. So it's a negative review, and ideally we also want to be able to be able to assess this severity in order to ensure whether you want to tackle these responses earlier. So what we can see is that we have initialized this sentiment classification pipeline, and we can actually make predictions on these tests, where there was a 1-star review, which is bad. So you would say that the severity is high. And then next, for the text, the topics, and the sentiments, we'll actually loop through each one of these examples and do some post-processing to ensure that we only take the relevant part of the text and actually start creating these records within Argilla. So what we can do now is have these feedback records with these examples where we can actually review each one of these. You can see that there's some suggestions for the questions that we've set up for the feedback data set that we now want to gather. And then eventually what we can do is actually shuffle these records and add these records to our Argilla instance and our data set. So in this case, you would go back to the data set, and what you end up with here is this initial annotation, your initial data set from starting with nothing and ending up with this initial data. Ideally, you also want to be able to, for example, during the generation, have some few shot prompting of actual examples that you might already have available in your data set. But these kind of things would already really help in order to ensure that the data that you actually generate is on par with the distribution in your actual real life data. And then you would more so use the LLM to do, for example, paraphrasing in a RAG-like setting, so to say. Additionally, Gabi has done a lot of work on ensuring that we can do model pooling so that we actually generate responses from multiple kinds of models at the same time. And that would also ensure that there's more variability in the data. What we can do now is actually label some of these records, actually go through some examples where we might say, okay, this is correct, the severity is high, here's a bank account inquiry. And then after we label these records and actually create this more high quality data set, what we can then do is actually go back to the Argilla ecosystem, initialize this training task for text classification, where we might have this text field that we want to classify as from the base text field that we've defined, and a label that we want to use for that. and that's the bank topic question label. Then we initialize the Argilla trainer with the dataset and the task that we've defined. We set up the framework setfit, so we can use, for example, Transformer, Spacey, and these kind of frameworks. But for now, we'll be using setfit for few-shot classification. And lastly, we'll use one of the smaller embedding models that's out there. And what this will do is actually initialize everything, do some data processing in the background, and you'll actually end up with initialized Argilla trainer. Within the Argilla trainer, you can actually see some of the data set information where it's available. You can see some task information, the trained data set that we're going to use, the column mapping that's going to be present, and some parameters that you might update, like the number of epochs and the iterations and these kind of things. So for this toy example, what I will do is just update the config to 1 iteration to really briefly train a model. But what you can see is actually the model being downloaded from the Hugging Face Hub, and afterwards we will actually directly start training the model with an output directory called my setfit model, and we will run like one prediction. And as you can see, we already have a trained, fine-tuned model that actually has this initial knowledge from the LLM within it, but then specifically tailored for this classification for each one of these labels in the dataset that we've defined before. So what we can do next is actually reuse the generated text, the generated reviews that we got from the initial step, and create a customer support response for each one of them. So we'll now use the same LLM and the same distilabel configuration and setup, but then in a slightly different way to ensure that each one of the input text that we've just generated will be responded to by the LLM in 3 different ways. And this is typically also the way how you would gather preference data that you might need for fine-tuning an LLM. So in this case, we will once again configure this data set, but we will be using the built-in task templates that we have, and we will be using the task templates for direct preference optimization, or DPO, with 3 responses. And when we create this data set, you can actually see the template that is being used. So in this case, we'll define a field called prompt. We'll also get a field called response 1, a field called response 2, etc., so that we can actually assess the preference of each one of these. Next, we'll once again create this data set from a dictionary, but instead of using all of the 100 of text, we will just use the first 10 as an example. We will once again define this task description that we've set up, where we in this case say, okay, you're a helpful customer service assistant instead of customer client, so to say. And this bank is called Argilla within the city of deep learning AI, and you will help the reviews or the customer complaints and requests in a supportive way, and you will ensure that it's in line with the bank standards. So this is the new generation task. And what we've also included here is like some moral phrasing that whenever the LLM does something bad, that someone will die. And these things are small prompt engineering tricks. Also, apparently, when you reward them with money, they're more inclined to, or the model is more inclined to respond in a positive or more helpful way. Next, we'll once again set up the vLLM integration, but then with the slightly different task that we've set up. We will actually be using a pipeline, and for within this pipeline, once again, we'll be generating text synthetically that we can use later on for this preference data creation. And this is actually a data set with 3 responses to each one of these incoming requests that we initially had. So then you have your entire scenario completely synthetically generated, so to say, where initially we created like this synthetic request coming in for customers, and then we actually iterate over this a bit more by creating synthetically generated responses for each one of these requests. And as you can see here, for example, there's this response within the data set, and you can already see that it's quite formal and quite adapt or quite fitting to the initial solution that someone might have in mind for these kind of things. We will then create a data set for Argilla, or we will add the records to the data set we've already created. And what we'll do here is take the initial input that we had, then assign that to the prompt fields within the data set that we created. Then the first generation, second generation, and third generation as the first, second, and third response within that data set. And next, what we'll do is add records to the data set and then open the data set so that we can actually see. And now you can see that there was an initial prompt, a complaint coming in from one of your customers within your bank, and the LLM has actually already generated 3 different responses. And what you can do now is actually label these responses as ranking them from 1, 2, or 3, if you actually prefer 1 as being the best response. And then you would go over like mimicking a real life scenario and actually generating your initial preference data set, so to say. And this is actually how you would gather your preference data in a semi-controlled way. And eventually, what we can also do is using these LLMs as preference labelers. So actually use LLMs to label the quality of each one of these prompts or the interactions that the responses and the prompts have. And based on this, you can actually directly get some ratings from your LLM and use these ratings to create some initial preference data. This is a thing that's currently not supported within the setup that I've done now, but this is more of a data set that this is more of a scenario that you might use for higher quality, more capable, more complex models, where labelers GPT-4 or LLMs like GPT-4, Prometheus, or UltraCM are more likely to provide ratings and evaluations for these kind of settings that are on par with human judgment. And the Llama 2 LLM that I've configured now is not able to do that. But yeah, just to show you the scenario and how you might use that within like the Prometheus model. And that's what this part is about. And I will share this notebook after, so you can actually have a look. But basically what the model is doing now is generating some responses and ratings for each one of these interactions. So within these things that we now need to do manually, we actually asked the model to provide an evaluation for each one of those. And then based on the evaluation, we automatically create a ranking for each one of these things. And then afterwards, your human annotators that will actually review these initial predictions only have to look at the more uncertain examples or the more certain examples to only fine-tune a little bit from going from your completely synthetic scenario that you've sketched in your mind to actually having this already pre-labeled preference data set publicly available. And that's the example here. Let's wait for a couple more batches so that we can actually push the data set to Argilla. But if anyone has questions in the meantime, feel free to ask as well. So this data set is now almost done and actually being configured. What we can then do is directly convert this data set to an Argilla data set. And based on that, also push this data set to Argilla once more. And then whenever the data set's pushed to Argilla, we can actually see the way that this preference data set is structured. In this case, we would have a slightly different structure with the inputs, generations, and then eventually also whenever you use OpenAI or one of the more capable models, we'll end up with the ratings attached to each one of them as well. And whenever you translate these ratings to a preference ranking, for example, if the rating for question 3 would be higher than 2, you also know that the preference for generation 3 or response 3 is better in that example. And Muhammad, you had some questions about RAGAS, or did you already answer that, Danny?
Yes, I shared some links to both our tutorial with Llama Index and Human Eval, and also I shared the weights and biases blog post, and we were discussing a little bit about RAGAS. I don't know if Muhammad wants to add something to the discussion.
Okay, then I guess not. If anyone has questions about anything, feel free to answer that question them. And otherwise, we're gonna say goodbye and hope to see you during a follow-up meeting. Tash, was it helpful for you to maybe showcase how you might generate response data for customer scenarios or also for doing some RAG data sets?
You're asking me, right, Gabriel?
Yeah.
Yeah, it's good. I was thinking like one use case, like for example, like a healthcare point of view. I don't know whether other stuff are here or not, there or not. When we are fine tuning any model with respect to the healthcare data, specifically, for example, hospital ecosystem, patient data, there is a lot of issues with data, right? And I'm not interested to share my personal healthcare data kind of thing. I was
No, no.
thinking to some kind of data set creation so that I can fine tune better models so for each and every task. Maybe like so recommending a perfect treatment or consolidating the symptoms and extracting the relevant information. Just I'm thinking to generate some kind of synthetic data using this one. Maybe, yeah, I had to explore and try it out once.
Yeah,
Interesting.
nice. Yeah, it sounds like an interesting plan. So that's also a thing that we've been discussing several times is to have a more
Mm.
RAG-like integration, so to say, for this label, where you might be able to link it to a collection that you have somewhere, and then based on some initial prompts that you've defined, go
Yes.
from there and then actually start generating data. That's a thing that we actually discussed this morning too.
Yeah.
Nice to
And
see.
one follow-up question, just for example, I am preparing, let's say, 1 million data set. Maybe if it is big, of course. Now,
Yeah,
how can be it will be balanced? How much confidence I can think that it is balanced?
as in the balance
For
within the
example,
RAG data.
yeah, for example, let's say for a patient is having a cancer or not.
Mhm.
So it having several features, right? So it may be genetic or his food condition or his problem, what is the beginning or ending. Maybe the futures, maybe a lot of the things are there. So for example, if I'm preparing, let's say that decision depends on, let's say, 100 factors. Let's say assume 100 factors to get the best model. It should be balanced, right? For example, all our cancer patient data means the model may be biased. So how much I can expect this is a balanced data set? What, how can I assure that kind of thing?
Yeah, so I think there are different scenarios. So one would
Uh-huh.
be the rack-like scenario, like where
Uh-huh.
you pipe in actual existing data, maybe steer towards some having a bit more variability in that way. And another
Mm,
way would be to use model pooling to function that Gabri introduced. And
mm,
this model pooling would, for example, use multiple models for data generation to ensure that there's a bit more variability, or maybe a model that uses a lower or higher temperature, these kind of things. So these
mm.
are ways that you can do it from a like
Oh,
more engineering point of
yeah.
view. But besides that, what you could also do is evaluate, of course, once again via humans,
Yes.
via doctors, or what you
Mm,
do is maybe assess the certain aspects in your data that humans actually know are relevant or irrelevant to have a look at. As in,
yes.
for example, whenever there's a example generated that's about a certain gender, or example generated that's about a certain subtype of symptoms or these kind of things, these are
Mm,
probably knowledge rules that your doctors or your like medical experts know a lot about, and that you
mm,
might add on top of your data set in order to assess the variability. And for example, if you then would see by,
mm.
by just doing basic if else or basic regex query that certain symptoms are way more prevalent than you would see them in academic literature, you
Okay.
might be able to correct for that within your prompt. You might be able to fine tune the synthetic data set or the initially generated data based on that.
Great. Because earlier, like couple of months back, we have done one use case, small POC,
Mhm.
where we got one marketing like kind of thing, promotion kind of thing, different promotions they are doing. So how the people are getting, they want to build some basic ML model, but they don't have literally any data. What they had given was they given some kind of categories, promotion, one day offer, Christmas offer, different kinds of offer kind of thing. So what we did was we generated data from, okay, 100 customers from Chicago, 100 customers from New York, from London, like that. We in India, we from across locations we generated data because they don't have data. Finally, we fed some random forest decision tree kind of model. Yeah, at the time we spend like couple of people and a week or week 1 week for creation and 1 week or two for evaluation and
Yeah.
modification kind of thing. I was thinking like how, because we think that based on my projects, I feel that synthetic data also one of the interesting and useful thing while developing the models. That's yeah, I mean
Yeah.
interesting. Thank you.
But nice to hear that it's also being used in practice, because we of course within on LinkedIn or socials you see a lot of research being
Yes.
done into that, and that's also the one of the reasons that we actually started creating this package, and it's the ultra feedback paper and the Zephyr model. Um,
Hmm.
but yeah, apparently it's also usable to kickstart projects in a real setting. And did you, after initially generating this data set, do you still improve on the model? Do you still capture feedback on these kind of things to also maybe make the classifier more efficient and smaller?
Yes, might be. We need to experiment further.
Hmm.
Yes.
Yeah, maybe Argilla would be a good
Yeah.
example for the usage. And what we've also share a package that I really like, but that's not really actively maintained. But these have some of these key knowledge rules to identify biases in data, in textual data, where, for example, if there might be a word indicating a gender within a
Mm.
text, then it would pop up as being potentially a gender bias towards one of these genders, similar
Yes.
to pronouns, religions, and continents. And I really liked the idea and the approach of this package. But there are others out there. So I believe Giscard is one that's more
Mm.
LLM oriented and will rephrase prompts that you send towards your LLM with some of these bias indicators changed out. So, for example, whenever you have a text talking about a man in a certain scenario, and then about a woman in the same scenario, but just stating that she's a woman, you would ideally have your LLM respond in the same way. Not being biased towards a certain gender, but in practice, LLMs have been trained on human data, and yeah, of
Yes.
course, they mimic real life, and sadly also the real life biases that are out here.
Yes. The bias, how what's happened in the human life, it is carrying out there, but we are not accepting that again.
Yeah, sorry, what did you say?
The bias which is being carried out from human itself, and
Yeah,
it is trained by model, but again human is not accepting that.
no, exactly. So that's also one of the important topics, I would say, but it's one of the most difficult as well. Yeah,
Okay.
there was this to be this scenario in the Netherlands too, where they
Hmm.
made predictions to check for welfare fraud. So whenever you
Ah.
would get subsidized from the a subsidy from the government, and then all of
Hmm.
these prediction models were actually filtering out all of the people in the Netherlands with a more exotic last name, so to say. And then these were double and triple and quadruply checked compared to the normal Dutch people with the really typical name. And it was a huge scandal, and eventually also led to the fall of the government now. That's really bad scenarios when these kind of models don't get monitored.
Yes.
Cool. Not sure if anyone has anything else to share, but otherwise, yeah, thanks a lot for the attendance, and hope to also see you in the following meetups. And feel free to join us in our Slack channel as well. We also discuss NLP and these kind of things, and we're always eager to help you set up NLP projects or Argilla specific projects. Thanks for your attendance.
Thank
Thank
you.
you.
Bye
Bye.
bye.
Thank you.
Thank you, David.